Thank you.
This meeting is being recorded.
Yeah. Mm, So let me just open my presentation. Is my screen visible? Hello. I think you're mute. Hello.
Sorry,
Yeah,
I was mute. Yes,
yeah,
and,
yeah,
I can see your presentation. It's okay. Thank you.
yeah, sure. So, my name is Abdullah, and I'm a master's student at Memorial University of Newfoundland, and I'm currently working on converting CO2 to methanol using photocatalytic technology. So, yeah, and oh, this is not moving. Yeah, and so here is the decarbonization challenge which the maritime industry is facing, which is to reduce the dependence on fossil fuels for using in their ships and vessels. As we know that the global methanol production has exceeded like 100 million tons annually, and also the shipping sector faces urgent regulatory pressure to adopt low carbon fuels. And as we know that the current technologies are energy intensive, due to which other technologies are preferred. So here we proposed a we proposed a technology which is for the conversion of CO2 to methanol using photocatalyst. So here we have this photocatalyst, which is synthesized using two semiconductor materials. And when the sunlight or the visible light are incident, when the photons are incident on the photocatalyst, then there is a shift of electrons which causes the conversion of CO2 to methanol. As we know that the CO2 conversion requires six hydrogen for converting it into methanol. So it's a six-step process. And this is the structure of the photocatalyst which we have, and mechanism which goes here for the conversion of CO2 to methanol. And these are very easy to synthesize as compared to other products. And even and one of them is more light sensitive than the other. So in order to make the mechanism accurate. And next, so we plan to actually make it a dual value architecture where we can sell the green methanol, which is produced using this process, and also the green hydrogen, which is produced in this process. Although we plan on the green methanol for now, later on we could integrate it with the electrolysis process in order to have more hydrogen. But why we go for green methanol is because it's a liquid fuel and easy to store, and this can be used as an industrial fuel or feedstocks and also as marine fuels. And so Myers is a company in Denmark which actually order like methanol fired vessels, and also Brazil runs some of its car on methanol. And this is the reason why this is such an attractive market. And we know that the global methanol market is valued at 50 billion, and also the methanol capable vessels which are ordered in order to meet the International Maritime Organization net zero 2050 targets and also we have the green premium pricing. So these are the advantages of using the methanol which is produced using this process, leading to reduction of 95%, leading to reduction of 70% CO2, and avoiding tons of CO2 which is produced at currently. Yeah, that's all. And I would like to know about your role, and uh, also about decarbonization. What is, how does decarbonization affect, and also about this, about your feedback on this project. Yeah.
Perfect. Thank you very much for your presentation. It's very interesting because it's in the source. Of course, the source is in the seawater, so it's very important, and is a very high feedstock to do that. However, I had my impression about the how can you manage the pressure of the CO2 and of course the pressure of the hydrogen, because in some state of our works we know that it's important to keep in mind the pressure, the high pressure of CO2. Of course, you have the option in electrochemical to increase this surface electronic transportation is good, but it's important to have first that hydrogen production first or all, like water splitting, and
Yeah.
after that you have to increase the CO2, this CO2 conversion throughout the more or less 1 to 3%, 1 to 3 relationship between hydrogen and CO2. So it's mean to take in account this because I saw that it's important to maybe on the on your project, your proposal, to take into account this kind of risk. Okay, so I think that is something important, and this is something about critical in mechanism aspect. Okay, that
Yeah.
is my problem. In my case, is in photo. I work in photocatalysis directly. In this moment, I'm just to trying to put in work the photoelectrochemical
Okay.
approach. However, it's important to know if your reactor can be able to keep this high pressure in CO2, because you can reach this hydrogen for the water. It's okay because you are using like sacrificial agent TEA, so
Right.
triethanolamine. So
Triethyl, I mean, yeah.
this is sacrificial agent. Yes, you can reach the hydrogen. Perfect. And the CO2, that's why I just imagine, and this is something that you have to take into account at the moment of to write your proposal. But this is a master proposal. That's it. Yes,
Yeah, it's kind of, yeah, master proposal.
yes, it's a master proposal. Yes, it's important to take into account this: the hydrogen versus CO2 proportion,
Oh,
because
yeah.
it's not, it will be difficult to reach the methanol because it's an equilibrium.
Yeah,
Okay,
right.
this is something about my experience. It's important to know that it's something about you need to understand that part because it's an equilibrium, and you have to reach this kind of conversion only if you have the possibility to keep these quantities in hydrogen and CO2,
Yeah.
because it's very easy to pass throughout methanol, okay, and after to reach methane directly.
Yeah, right. So the process of the conversion to methane and methanol, it depends on the photocatalyst, right?
Yes, of course.
Yeah, so it depends on the mechanism which is taking place in the photocatalyst itself. But our target product is methanol, and we aim to do it for methanol. So, and this
Mhm.
photo catalyst which we designed, we tried it in the lab, and we are still trying to understand the mechanism so that more and more methanol is getting produced. Yeah.
Okay, and what is the semiconductor that you are using in case of the photocatalyst in this case? You are using a semiconductor or you are
Yeah,
using
yeah.
a semiconductor plus another one.
It's a
It means
semiconductor plus another one. Yeah.
yes, so it means two kind of semiconductor
Yeah.
or maybe a semiconductor with another metal, maybe it could be okay.
Right,
So,
right.
but it's important to first of all see which is the relationship between this capacity of the semiconductor to reach the pressure, to keep on the surface, to capture first one is to capture the CO2 and to produce the hydrogen at the same time. Okay, it's
Right.
something about the experience. Okay, so
Yeah.
but it's important to keep in mind. No problem. Okay.
Yeah, right. Yeah, yeah. And also, what would be some of the safety standards which we would require in order to bring this methanol into the market?
Sorry, can you repeat, please? Sorry.
Yeah, sure. So what are some of the safety aspects that or the regulatory compliance that needs to be studied before bringing this kind of green methanol into the market?
Well, I think the most important thing in the case of the subject is precisely the source, of course, okay,
Yeah,
and to have a very good LCA analysis, okay, techno-economical analysis, and of course to see how much the catalyst in terms of preparation, in terms of reaching the origin of this methanol, okay, is important. I think that this is most important. How green is your method to reach this product? Okay,
yeah,
because it's important the techno-economical assessment, for example,
yeah.
life cycle assessment as well.
All right. Yeah. So yeah, you're right. And also about, so what are you currently working on? And what's your, so you said that you're working on photoelectrochemical method.
Yes.
So
Mhm.
what's your target product?
My target product at this moment is reaching methanol from CO2. However, my source are from water, okay, and wastewater as well. Other of my targets are in biomass and trying to produce hydrogen from biomass,
Okay.
lignin, cellulose, and hemicellulose. Okay?
Oh,
That is my target at this moment.
so you worked on, so you so you use visible light and also use electrolysis and also use chemical, right?
Yes, I have my, for example, depending on the semiconductor, we can use UV light,
Yeah.
and we can reach more of the wavelength range, making some interaction between semiconductors, okay, and using metal on the surface. We can reach more. For example, I usually work with copper, gold, and silver, that which are the three noble metals that are more from plasmonic bands.
Yeah.
So it's something about how to widespread the the UV, or sorry, to widespread the wavelength range.
And so that's the process. And how about, are you doing some computational chemistry also, like simulation?
No, not yet, because, for example, in my case, I used to use as well ionic liquids, and the ionic liquid is a matter that is very complex. So it's important to know if you have a complex system, could be a little bit challenging to use computational studies as well.
Yeah, right. That's great. Nice to meet you, and your insights were also a good one. And are there any safety aspects? So that question, are there any safety aspects that we need to think while using methanol as an alternative fuel?
Well, in fact, in my experience, of course, trying to look for the methanol is possible to see how effective is your catalyst to produce hydrogen, for example.
Right.
Yes, we have a big problem with the carrier, hydrogen carrier, for example. But normally, when you try to produce methanol, the first product that you will be in contact will be hydrogen. So you have to taking into account that the possibility to modify many of your conditions to create, sorry about this, but this is to create the condition for generating this methanol, and not only generate hydrogen. But the hydrogen is a good vector, energetic vector that
Yeah.
can be other
Right.
option. Okay.
Yeah, yeah, that's right. Yeah. Um, and also like, so when you are still at the research level, right?
Mm-hmm.
So
Yes.
are you, so do you even plan to commercialize your project or in that sense?
Well, in the case of photoelectrocatalysis, is something about this is very integral, very low. Okay, so
Yes.
2, 3, 4. However, we are planning to create the condition to try to a higher
Here.
TRL level. For example, in a pilot plant, that
Yeah.
could be interesting. But it's something about we are planning for future.
Right. Yeah, that's great. That's a great insights. So I've just forgot, like, you're from which university?
I'm from ETQ, Institute of Chemical Technology in Spain.
Oh, yeah, that's great. That's a great one. I think that we have
University,
seen.
Polytechnic University of Valencia. This is a mixture of
Oh, yeah,
institution.
sure. We'll stay in touch and even look for further collaboration too. So,
Well, of
yeah.
course, no problem.
So currently
You can reach.
yeah, I'm working in the lab on this. So I have synthesized the photocatalyst, and
Okay.
I'm trying to produce more and more methanol. Uh, the challenging part, yeah, that's right. That's the CO2, getting it dissolved in the water, and also to
Yes.
lead the conversion, and also to actually read the part. So how which I mean, which machine are you using in order to detect your products for liquid
We are
chromatography?
using this normally used to use the GC, gas
Yeah,
chromatography.
yeah,
Okay,
we
so
have the we have.
uh, we normally have or uh, by injecting the gas phase, okay,
Mm,
the places of gas phase, we can inject gas phase directly on the apparatus, or we can, in the case of electrochemical, we can connect directly with a micro GC. Is connected online, so you can connect it, and periodically the apparatus take some samples and inject. And for the part of liquid, we use APLC, okay?
oh,
High pressure liquid chromatography.
so you are trying to detect methanol using HPLC?
We can detect methanol by APLC, and we can detect methanol as well by NMR, okay? So
Okay.
mainly in HPLC, mainly.
Oh, okay. I think we are trying to find methanol using GCMS.
Well, it's possible as well, but you have to create the condition. However,
Yeah.
in HPLC is more accurate. to do this kind of detection. Mhm.
Oh, that's great. That's a good one. Like, this is the great insight. So I'll take it for
Yes.
record and work on it
It's
using
better.
PLC. Yeah,
In fact, it's better because you can use each PLC plus uh, spectrometric mass. Okay,
yeah, right.
that you can create
Uh,
the
how,
both
and
online.
how about the gas product? So, you use the online GC, right? For the gas
Yes,
products.
yes. The gas product in apparatus, okay, in
Yeah,
GC, and another is in liquid. We can analyze the liquid phase by HPLC
yeah,
as
that's
normal.
great.
Okay,
Yeah, that's a great one. Thank you so much. So
okay.
it was
You're
very
welcome.
good chatting with you and also to know about the project and also you have providing feedback on the project and to improve it and also
Okay.
as part of Ocean Idea Challenge. Thank you so much and looking
Well,
forward to stay in touch and we look forward for further collaboration also. Yeah, that's great.
of course,
Thank you.
of course. Well, thank you very much for your invitation, and of course, I'm open to any collaboration in the future. Thank
Yeah,
you.
sure. That's great. Thank you.
Thank you. Bye.